Welcome to another Dolphin Communication Project Deep Dive. Thank you to those who are listening live and to anyone who's listening to the recording. We are honored today to have Dr. Audra Ames. She is very busy and we're grateful for her time. Dr. Ames studies the communication and echolocation systems of belugas, dolphins, and narwhals. Particularly, she spends time in Spain and Greenland. She is also a founding member of the Marine Mammal Research Network, which you can learn more about at marinemammalresearch.org. As always, we'll keep questions until the end. So if you're listening live, just utilize that chat function. And if you are listening to a recording and you have questions, just reach out and we'll try and get back to you. With that, I will pass it over to you, Dr. Ames.
Thank you guys so much for having me here this afternoon. It is always a pleasure to talk about my favorite species and particularly one of my favorite behaviors. I am talking about pretty well. So I'm Audra, bio sticks and that I choose to that's all of your species like your sperm whales, all of your dolphin species, including your killer whales and your pilot whales. And then that also includes these like your belugas and of course your narwhals. So I'm going to be talking about the communications of those guys today. Just to start off, I want to briefly talk about toothed whale sounds because toothed whales are species that are heavily reliant on sounds for survival. And they do this through two ways. I'm sure most everybody that is listening these bioacoustician do around go for food. For those that don't look like, hopefully so that you can okay, so now starting to hopefully we won't have that problem again. Okay, so I'm going to play that sound and hopefully everybody can hear me. Let's see here. Please turn your volume up or maybe down accordingly. So this is what narwhal echolocation actually sounds like. So you can hear that rhythmic metronome type sound that an animal is sending out a pulse into its environment and waiting for information from that pulse to come back with hopefully some goodies that are out there in the environment for some foraging or for some navigation. So the other way that toothed whales heavily rely on sound is through communication signals. So these are absolutely critical for maintaining contact with social group members, for advertising where food is. So for example, bottlenose dolphins in Scotland use brays where they try to tell their other social group members, hey, there's food over here. And then what I'm going to be talking about today, most importantly, is that some of these calls actually broadcast an animal's identity. Sorry about that echolocation again, having some continued technical difficulties. And so talking about those communication sounds, for the more complex vocalizers, these are animals like your belugas, your killer whales, your pilot whales, and of course your narwhals. We tend to divide their vocal repertoires into three main sound types. So this is comprised of pulsed sounds, and pulsed sounds is a pretty broad category for basically describing calls that are defined based on how quickly the pulses are being produced together. So you have these very high pulse repetition rate sounds called burst pulses, which sound like a whine or like a squeak or something like that. And they sound, you can hear that. Let's see. Okay, so that's what a burst pulse sounds like. And then there's also other examples of pulse sounds like what we call pulse trains. And these are signals that are less condensed. There's more space between each individual pulse. You can actually hear or count all of the pulses in the call. So those sound something like this. Sorry, that's the first pulse again. There we go. There's the pulse trains. These guys also produce tonal sounds or whistles, so that these signals actually sound like what human whistles sound like. So there's an example of a narwhal whistle. And then finally, these complex vocalizers produce what we call biphonations, or sometimes you'll hear them called mixed calls. And that's because these are sound combinations. Most commonly, we see them in this pulsed, with this pulse component overlapped by a tonal component. With killer whales and pilot whales, you can see that as a double tonal component. With belugas and narwhals, you can see that as a double pulsed component. So you have two of these pulse components overlapping each other. And so this is what a biphonation sounds like. So if we could hear that pulse train with that whistle overlapping it. And basically what I'm going through when I'm looking through vocalizations and data that I've collected is for my work, going through and looking for what we call stereotyped calls. So stereotyped calls are essentially all versions of a call that look and sound almost identical. And when I say look, we're again looking at that spectrogram that science has used to be able to visualize sound. And so every time I see this sound on a spectrogram, like this example here below of a dolphin signature whistle, you can see that those contours, those shapes of each one of those whistle iterations, there's 3 here on the screen, each one of those looks very similar. And they sound very similar too. So here's an example of what this whistle sounds like. And the reason why I look for stereotyped calls when I'm going through acoustic data is because a lot of times in the animal kingdom, stereotyped calls can mean individual specificity or maybe a group specific call. So, and that's certainly what we have here when we're talking about the bottlenose dolphin signature whistle. So I'm pretty sure most people in this audience are familiar with the signature whistle, but just in case you're not, this was a communication behavior that was discovered by Melba and David Caldwell in the 1960s. And they found that when bottlenose dolphins that were in their care were separated out for regular daily husbandry procedures or for veterinary procedures, that these animals would produce a whistle over and over and over again. They produced this stereotyped whistle. And each dolphin had its own distinct stereotyped whistle, meaning that the whistle that this animal over here was producing repeatedly was different than the whistle that this animal over here was repeating repeatedly. And that signature, that stereotypy actually comes from that contour shape. So actually, again, that the shape, that the frequency modulation that is occurring while the animal is actually producing that whistle. We also always see these whistles produced in repetitive sequences. There seems to be some ebb and flow, almost conversational type criteria emitted between these signals. So animals will typically produce a whistle and then wait a second. They're lingering a little bit, waiting for an animal to respond. And then they might start calling again. And they typically don't wait longer than 10 seconds. So there seems to be this minimum of 1 second, potential maximum of 10, 15, 20 seconds. That these signals seem to follow. So to give you an idea of how signature, really how different each of these signals can be, I'm going to play that signal again. And this is from Bella. This is a signature whistle from her. She's a bottlenose dolphin at Six Flags Discovery Kingdom in Vallejo, California. But now this is Billy at Oceanographic in Valencia, Spain. And this is Neptuno. So you can see that the wee, wee, and the wee, like are all very different. So what do these mean? How do animals actually use these calls then? They're really, really important for maintaining contact. And we know this through studies of signal use between mothers and their calves, between social group mates, between close associates. But really, two studies that demonstrate how critical these signals are to communication in this species are one that was done by Sayai and colleagues, Layla Sayai and colleagues on the Sarasota dolphin population, that showed that mothers and their offspring could recognize each other for up to 14 years after a calf had left the mother-calf dyad. And Jason Bruck in his PhD study showed that that former poolmates in managed care were able to recognize each other for up to 20 years after being separated. And just to note that those are actually limitations of the relationships within the study. So potentially you might have had a mother and calf that were separated for longer. They might have recognized each other longer, but 14 years was the max cap for that study, and 20 was the max for Jason's study. So that long-term recognition shows how critical these calls are to the relationships that these animals have with each other. And one other way that we know that these are critical for maintaining contact is because they're used for identifying animals. And I will talk about more, I'll talk more on that in just a second. And we see this through studies of signature whistle imitation. So Stephanie King and colleagues in 2013 with bottlenose dolphins in Scotland found that animals would use each other's signature whistle to reference each other. Now, why is that important? Well, if we're actually talking about what a signature signal is in the animal kingdom, the Caldwells jumped the gun a little bit in calling these signals signature whistles. Luckily, they are signature sounds, but if we're talking about actual true signature signals within the animal kingdom versus calls that are just individually distinct, true signature signals are a lot more rare. So basically, with individually distinct calls, remember again that I showed you each one of those bottlenose dolphins has a whistle shape that's different. So that's qualifying as being a call that's individually distinct. But individually distinct calls are quite common in the animal kingdom because you have things like morphology. So an animal's physical development can affect how they produce calls, and this can cause individual variation between different calls. So, for example, the vocal tracts of koala bears. Formants are different in which are these patterns that are produced in certain sounds that koalas make. They're produced in vowel sounds that human beings make. It's basically how our vibration of our vocal tract is playing into what our sounds look like on the spectrogram. And koala bears that are adults that are male will have a lot different looking formants than smaller animals. And so you can get individual distinction through calls in that way. But what bottlenose dolphins do and other animals that use true signature signals are doing are they're using signals that broadcast their identity, and they're doing this through designing a signal, meaning that they hear a sound in their environment, and there are learning processes involved. So a particular vocal learning, which requires an animal hears a sound and then takes that sound into its own repertoire and begins to use it in its own communication. And so basically what happens here is an animal hears a signal out there in its acoustic scene, and it's like, I like that signal, and I want to be able to use that signal to address, to reference myself. So the take-home message here is why signature signals are so special. It's because they broadcast identity in a way that is referential to the animal that owns the signal. So that's like me saying, my name is Audra. Everyone in, my social group or the room that I'm standing in at that point will know that when I say Audra, they mean I'm talking about myself. But if the person standing to the right also says Audra, as human beings, we all assume that that person is still referring to me. And that's what these animals are doing with their signature whistles. So all vocal signatures are individually distinct, but not all individually distinct calls are signatures. And that's because you need this behavior of actually representing, having a reference to an animal based on that signature signal. So I just heavily dove into what a signature signal actually is, but yes, just to reiterate, they represent the owner, they broadcast ID, but this is incredibly difficult to test. And we have rigorously tested this in bottlenose dolphins because there are groups both in managed care, but also in the wild, the Sarasota and Shark Bay populations, the Scottish populations, where this can also be rigorously tested. And from those studies, we've learned that bottlenose dolphins do use their signature whistles referentially, that they do this whistle copying behavior. Now, I've heard sometimes that signature whistles can be called equivalent to that of human names. And while it does quack and waddle like a name, it's more like a name if I were to pick my own name at around the age of 1 or 2, and then use that basically to reference myself, and then have everybody else use that as well. So it's a little hard to pigeonhole this behavior as one that is similar to human beings, and I tend to not like to do that anyway, because we're talking about the behavior of another species, and what they do is and can be totally different to anything that we're familiar with. So I do want to be careful about that. When asking whether narwhals do have names, I would tell you that they have individually specific signals, which we'll talk more about in just a little bit, but I would be hesitant to ever call it a name. So these are calls that, again, are individually specific, and we start recognizing them through that stereotypy. And then again, they follow that time-specific ebb and flow. But when we're talking about species outside of bottlenose dolphins, and delphinids kind of in general, although there are delphinid species that don't produce signature whistles like killer whales and pilot whales, when we're talking about species outside of dolphins, we start to have a little bit of a harder time in trying to figure out whether they have signature signals. And that's because we have species that are producing non-whistles as potential signature sounds. So you have animals that are producing pulsed sounds or biphonations. So this is Kilu, one of the animals that I work with at Oceanographic. And instead of saying I'm Kilu, he's saying I'm because here's this pulsed sound, and you can see it being overlapped by this dark line. This is what we call a tonal signal, a noisy tonal signal. So there's two sounds there that are being produced instead of that whistle shape. And we really have to take social structure into account when we are trying to look at potential signatures in a new species, because a lot of times social structure tells us a lot about the communication styles of these animals. So, for example, bottlenose dolphins produce signature whistles because the hypothesis there is that they live in fission fusion societies, meaning that they have 1 to 2 close associates. They are bouncing around between many different social groups with those associates. So it's better to have an individual identifier, because the individual is the one that is maintaining the relationships that it has. Whereas with killer whales, these are matrilineal societies, meaning that animals are more focused and centered around the matriline, and they have a group signature. So killer whale pods each produce calls that are specific to that group, because most of the time the animals are within that group. So it makes sense that groups would need to be able to identify each other. And one great example of this is when we're talking about belugas, because not just a short while ago, back when I was doing my PhD, we believed that belugas were potentially matrilineal based. And my PhD study, as well as the study of my PhD supervisor, found that calves in managed care tend to develop the sounds that we think are their potential signatures, similar to that of their mothers. So we were wondering if they were developing these group dialects. Well, shortly after I published my PhD, of course, Greg Corey Crow and colleagues came out with an excellent paper showing that belugas are probably more fission fusion. And so this kind of opens up, well, then are we looking at individual signals as potential individual signatures? So do these quack and waddle like bottlenose dolphin signature whistles? And the answer is a very, 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 very tentative maybe to yes. I hate saying anything definitively. But it's because we have everything except for that proof of ID concept. So we have all of the characteristics that these sounds, quack and waddle like signature sounds, except of course that most critical one, that last step, which is that these sounds represent the individual producing them. So we don't have ID yet. But to give you a little bit of background on what I mean when I say we have everything other than, these calls were originally noted by Sophie Van Perrie and colleagues in 2003 in Svalbard. And they separated animals out. So remember that I mentioned that these calls need to have some sort of contact association with them. They're contact calls that we see animals producing when they are separated. This is exactly the behavior that Sophie Van Perrie saw in 2003. And so that was kind of the first identification of these calls that belugas produce. Then in 2008, my PhD supervisor, Dr. Valeria Vergara, really found that these were very context specific. They were being used between a mother and her calf. And she was the first to really identify that these could potentially be individually specific signals. In 2010, she showed more evidence for this in wild animals. She showed that wild animals used these contextually the same way that animals in managed care facilities do. In 2013 and 2015, the Morisaka and Mishima teams out of Japan started to look for the potential signature information in these calls, focusing more on the pulsed element. And then in 2017, Elena Panova showed that belugas in managed care each had their own individually specific call, and that these calls were complex, meaning that they were biphonations. They had that two call component. And then finally, Valeria published again in 2018 showing that, yes, these calls are individually specific. We see this in the wild as well. Here are these potential signature elements, doing a very thorough investigation into these potential signature calls in belugas. So again, just to reiterate, they are context specific. We see these being used to maintain contact between conspecifics and kin. They are individually specific. They're highly, highly stereotyped. And for belugas, this looks like calls that are broadband, meaning they always have this pulse component, and calls that are long in duration. So we usually see them being produced over about 0.7 to 1 second in duration. And then again, we see them following that same ebb and flow that signature whistles follow. So that repetitive time-specific sequences. And just to play you an example, this is Cairo, our big male oceanographic that unfortunately is no longer with us. He passed away in 2022. But again, listen for that stereotypy in these calls and listen for that kind of conversational pause, that ebb and flow as Cairo waits for a response from other animals in the social group. So that is a very, very typical beluga contact call. So I've already kind of given away some spoilers. Would we consider these true contact, or these contact calls true signatures? I would say yes, but at this point, we still really need that proof of ID. And so how can we get that? Well, you might have remembered that I mentioned those learning processes involved, and in particular, that vocal learning process that requires an animal can hear a sound in its acoustic scene and then incorporate that and use it later on. We can start teasing apart whether animals might even have the ability to produce signature signals by looking for that learning processes. And that's some of the work that I'm actually doing right now at Oceanographic, is really trying to focus on the learning requirements for contact call development. Now, if we're moving on and talking about narwhals, the story gets even a little bit hairier, because it hasn't been until recently that we've really started to talk about these stereotype signals that narwhals produce. So for those of you guys that are unfamiliar, why are we moving from belugas to narwhals? Well, narwhals are the super close cousin of the belugas. These are the only two monodonid species. Unfortunately for us, this means that they actually vocalize quite similarly. So we can extrapolate some of the information that we have found for belugas and try to see if the behavior is similar for narwhals. It gives us a good place to start testing things. So these stereotype signals were first noted by Ford and Fisher back in 1978 with a single hydrophone. They were kind of noticing that these similar calls were going up to and then past the hydrophone, like animals were approaching and then swimming away, indicative that maybe these signals were individually unique. But that question really wasn't addressed until Ari Shapiro came around in 2006 and tagged two animals, two Canadian narwhals, and found that each animal had its own biphonation and own whistle that was different than the other tagged narwhal. And so we had this first glimpse of whether these calls were actually individually specific and worth kind of investigating a little bit more into that idea. And then in 2021, I'll go a bit more into this study on the next slide, but we were able to show that for 4 animals, there were potentially 4 individual calls. But are these calls used in a contact scenario? We were able to study this opportunistically in a narwhal mother and calf. So in 2021, as part of a bigger study, which I'm going to again talk more on in just a second, on individual calling in the East Greenland narwhals. This mother was tagged as part of that study, and during the tagging event, they noticed that she had a calf off to the side. And while the mother, Isla, was being tagged, she was producing this sound that the tagging team could hear. And that sound was continually heard until after the tagging event was over and she presumably reunited with her calf. And we have that, of course, on the tag as well. And out of 17 animals that were part of that larger study on individually specific calling in narwhals, she was the only animal to produce sounds during that tagging event. So that is some pretty good preliminary evidence that these calls are important for mother-calf communication and in particular for maintaining mother-calf contact. So just to give you an idea of how narwhal contact calls quack and waddle, this is what Isla's sound is like. So you can see again that there's that waiting period, that ebb and flow. You can hear hopefully that it is a little similar to that beluga contact call that I showed you because there is that broadband pulsed quality to both sounds. Now, just for funsies, I want to tie in a little bit of another example on how social structure can be important in trying to tease apart these signals. So I just played for you Isla, our mother from that study, her signal, and here it is again. But what we found actually when we were going through the data was that there was this second call type that was really commonly produced either before or after Isla's call, almost like it was in call and response. And it was there through the whole record. And we felt so strongly that this was Isla's calf based on what we know about how belugas develop their vocalizations during the early years of their life. So belugas don't actually have a fully stereotyped sound until they're about 2. So when I saw this sound that was looking almost stereotyped, but not fully developed and there through the entire record, it was a pretty good guess that that we felt like we had the calf signal recorded as well. So that was Isla's signal. This is the calf signal. It's that biphonation that I played you from the top of the talk. And I'll play him again just one more time. Ah. Notice how different the two calls are. And remember when I was saying that beluga calves develop, in managed care, seem to develop contact calls that were similar to that of their mothers. This would, knowing what we know about how bottlenose dolphins develop their calves in, or their signature whistles in the wild, they develop signature whistles based on sounds that are peripheral in their acoustic scene, which makes sense. They choose a sound that's not going to be heard very often within the social group that they're already inhabiting. So this would lead me to have a hypothesis that narwhals are potentially fission fusion as well, given that we have a calf that is developing a call that is very different to its mother. So do narwhals have signature calls? They do have calls that are highly stereotyped. and they do have calls that appear to be context specific, although we definitely need some more evidence. We just have that one contact scenario. We definitely need, and that's a great jumping off point, but we definitely need some more evidence to support that they are context specific. They are broadband and long in duration, like those beluga contact calls. So again, these are more characteristics that are specific to narwhal signature calling and less to bottlenose dolphin signature whistles. We do see them in those repetitive sequences, but I haven't really gotten to whether or not they are potentially individually specific yet. I've started to talk about it a little bit, and before we can really talk about whether these calls broadcast ID, we need to talk about this first. So I mentioned that larger study on East Greenland narwhals, looking at whether these animals had individually distinct calls. And we tagged 17 animals. We ended up with 18 acoustic records because there was one animal that was tagged in 2 consecutive years. And myself and my colleagues scoured 22,000 narwhal calls manually and over 3,000 hours worth of data looking for those stereotyped signals. And we basically pulled out all of the stereotype signals that we had a hunch about, and took years classifying them and sorting them and trying to figure out if each whale truly did have its own individually specific call. And fortunately for us, in the end, it really did turn into this incredible puzzle where we had found one call for each animal. So to give you a little taste of what that sounds like, here are all of the contact calls from the hypothesized contact calls. Here are all of the individually specific calls that we have found for that study. That's like literally my favorite slide of the time, just because I love hearing all of those sounds in one place. So hopefully you're able to see and hear all of the incredible differences, and even the very simple differences that are there between each of these calls. We did have one pair of closely associated males that shared a call, so we're looking into that phenomenon a little bit more to see if there's ways that we can separate out those 2 calls and potentially what the animals had converged on there. That's super interesting behavior that we're wanting to look a bit more into. But going back to it, are narwhal contact calls true signatures? We're still looking for that contact call proof. We still need that proof of ID. We've just begun to scratch the surface of whether these calls are individually unique. Hopefully, I'm giving you an idea of how difficult this behavior actually is to study, because we have gone through 22,000 narwhal calls and are still not comfortable saying these calls are individually unique. Because we need to go to other populations. We need to see if Canadian narwhals do this. We want to see if the narwhals in North Greenland do this. And if these other populations do this, I will explain why that's important in just a moment. So we still need that identification. We still need to do a little bit more digging into other populations and other contexts to see if this behavior is staying stable in other narwhals. So do narwhals have names? Not quite. My point would be that we need to that we need more research to just determine if these signals are truly individually specific before we can go on to broadcasting ID. But I did mention that this was incredibly important, and why. Why is it important to know if narwhals potentially do have these individually specific calls? Well, we can use them in tracking and monitoring social groups and populations. So, for example, if there are differences between Canadian narwhals and North Greenland narwhals and East Greenland narwhals, can we find those differences and use that to tell us if populations are moving, especially during this period in the Earth's history when the Arctic is changing faster than it ever has before, and we are experiencing climate change, and the species that are in this point in history with us are experiencing climate change. Narwhals are niche conservatives, meaning they like very cold, very deep water, and so they are becoming one of the most vulnerable species to what is going on with our planet at the moment. So being able to have a way to monitor where these different populations are going is extremely useful in determining how climate is going to affect these guys. And then even within the larger populations, you might be able to keep estimates on how many animals are within these populations, because if I have social group of Bob, Bill, Kevin, Tim, Mike, and Andy, and they show up together year after year on our passive acoustic monitoring devices, and then all of a sudden Bob's not there, and then Bill, maybe the next year Kevin and Tim aren't there, then we just see Andy and Mike for the next few years. That's a pretty good indicator that potentially the rest of those animals, something's happened to them, or maybe they've moved to a different area, or their social group is separated, or maybe they've passed away. So it's a way for us to keep tabs on the individuals as well. So with that being said, thank you, and I will definitely take any questions if we had folks joining us. And apologies again about the technical difficulties at the beginning.
No problem. That happens. Usually it's me who's juggling some internet issue or something like that. So we are very accustomed to rolling with it. We have a few minutes, so put in your last questions if you haven't yet. And I often feel like I have an order for the questions, but I don't this time. So I'm just going to go with the order that they came in. When you showed some of the spectrograms from different beluga or publications on beluga data, the 2010 data, and maybe a later year's data too, I think you said it was your PhD advisor. I was just wondering which wild belugas were being studied.
So Valeria studied the St. Lawrence belugas, and I believe that 2010 study was done with the St. Lawrence belugas. She's also done some stuff with Hudson Bay belugas as well, but I don't know that she included them in that 2010 study. But the Vancouver Aquarium belugas were the one in the 2008 study.
Thank you. Can you tell us what a narwhal, these tags, what they're like physically? I think the person means like, what do they look like? What part of the body do they go on? And then what information do they give you? Is the tag itself making the recording, or are you getting other data as well? What are the narwhal tags?
Yeah, of course, man. Good question. I wish I brought an example to show. So when we are tagging animals with acoustic recording devices, usually these devices are suction cupped onto the animal. So if you've ever heard of a D tag, that is essentially how the tag is deployed onto the animal's skin. It just suctions. You get a little water underneath the suction cups and just suctions right on. That's super useful for studying animals for a short period of time. For studying the length of
And
records that
short is like hours,
several
days,
hours.
weeks.
Yes, several hours. So they pop off after a certain amount of time and then are recaptured by the research groups. What can happen though with D tags and using that methodology is if you are doing things like capturing belugas or capturing narwhals, you have an effect. You have what we call a tagging effect. Animals will be quiet following being tagged. And so for this study, what was actually useful was we used an Akusan, which is a different acoustic recording tag. And that was threaded through the dorsal ridge with a very thin, I can't remember what the material of the thread was, but a very thin, I think it was nylon, thread through that dorsal ridge, which is not as invasive as some of the older ways of tagging animals, which you might remember have big barbs and darts and guns and things like that. This is much less scary. It's kind of like a little bit of floss through the dorsal ridge, and then that tag actually stays on long enough to avoid those tagging effects. We end up getting records for 5, 6, 7 days, which can be excellent. And then I can't remember. I know that there was a multi-part question, but
Is that, I mean, I would say, I don't mean, is that it? Only acoustic data, but is it strictly an acoustic tag, or does
yes.
it also provide anything else, diving depth, location, anything like that?
Yes. So some of these acoustic monitoring tags also provide a lot of behavioral information too, which can be incredibly useful. So GPS location sometimes, dive depth, animal positioning in the water column. So whether an animal is turning around or going up or going down. So there's lots of really helpful things that can come from these tags as well. And we use a lot of that information. So for the narwhals, especially because they're deep divers, we're using that depth information commonly to see when are they producing these signals.
That's awesome. And I just love it when you can get like a lot of bang for your buck in
Oh
data
yeah.
collections. Um, Can you return, you mentioned the criteria of learning in defining something as a signature signal. Can you return to why that's an important component?
Yes, for sure. Um, so we have a process that we've identified within marine mammals called vocal production learning. And basically, this is when an animal hears a sound in its acoustic scene and basically incorporates that sound into its repertoire and uses that sound as part of its signature. So it's basically learning and processing and going through all of the sounds that are out there in its environment before actually going, oh, I like that one. And I have the ability to recreate that and use that for myself. And so that is not only a very cool thing that dolphins can do, and hopefully these other toothed whales can do as well. But it leads to that signature information because it means that one, other dolphins have the ability already built in to produce that animal's signature whistle. So they have that inherent ability to go ahead and copy somebody's whistle to be able to reference that animal. And it gives enough differences in between sounds that animals can pick a sound that's unique to them to become that referential signal. So that learning behavior is so critical in how these animals design and produce those signature sounds.
Amazing. These are just really, really cool creatures out there. Um,
Agreed.
what would you say the biggest challenge to studying narwhals are? Like, I think narwhals now are, I mean, maybe not to the extent of like when llamas became really popular, but like they're cool, yet
Yes.
I would venture to guess that the majority of our listeners, myself included, like I have never seen a wild narwhal, therefore I have never seen a narwhal. Um, since it's, kind of a well-known yet very, very unknown, unfamiliar species, can you share a little bit about what some of the challenges in studying a creature like that has been?
Yeah, my colleagues would absolutely have far more to say on this than I would because they've been in the field of these guys for many years. But I would probably say just the logistics of finding the animals, which is kind of a thing with all field work, is you
Mhm.
got to find the animals to be able to see what they're doing. And these guys are extremely elusive and live in places that it's not super easy to get to. And I know that many colleagues have been extremely reliant on the native hunting populations to be able to track the animals and find them. And so, yeah, I think probably just the logistics of seeing the animals and finding them is probably the most difficult thing because they are so shy.
Well, thank you to you and your colleagues for sticking with it and getting these data and processing them. That is a lot of hours that you all have put into listening and watching those spectrograms. So thank you very much. And then before we'll wrap up, I will just head remind people where you can find our webinar recordings. If you go to dolphincommunicationproject.org, look under that Knowledge Hub, you'll see the webinars. And so usually within 48 hours, we get them posted if technology cooperates. And then this was a deep dive, so you can see Dr. Ames did not shy away from sciencey words and topics. We also have dolphin lessons, which are a little bit more accessible. So we kind of say they're geared toward ages 6 to 11, but I think they're geared toward everyone. And then if you've listened and watched all of our webinars and you still need more, make sure you check out the archive of our podcast, the Dolphin Pod. And hopefully we'll have some new episodes out next year. And then, of course, DCP is a nonprofit, so we need our supporters to make sure that we can continue to offer these programs free of charge. One of the ways you can do that is by becoming a dolphin protector, which is a fun kind of educational and conservation-minded gift if you need to shop for someone who's difficult to shop for. And then stay in touch, even if you're just utilizing our education programs, our social media posts, join us in the field. We hope to hear from all of you very soon. And with that, I will thank you again, Dr. Ames, for your time, for your expertise, for your willingness to get to those questions. And we hope everyone has a great rest of their day.
That was awesome. Thank you again for having me.
Awesome. Bye, everyone.
Bye.